me about that. Today I have a plan to start something talk about confirmations. So we would like to discuss the what is confirmations, how we can explain the confirmations. So if before that, let me ask one question that yes, let me ask one questions. So okay, can you see this structure? If you can see this structure, uh, so red is OH. So let me draw also for you. So, let me draw also. So let me share screen also. Oh, two things together can't go, right? Screen and video. Hmm. So, do you able to see the screen also and video also? Good. Okay. So now let me draw. Okay, I would like to draw now. So suppose you have whatever 4 groups. I want to draw 4 groups. So I hope you are able to see that one is OH, that is red color. One is OH and another is green, right? So another is green. Maybe that green is maybe CH2OH. Okay, maybe this is green, and yellow is suppose CHO. This is yellow, and white is hydrogen, and center is the carbon, that is black. So this is the structure what in front of you in you have now. So this is the structure what you have now. Can you tell me this structure, whatever is on paper, this structure is R or S? Whatever is on paper, is that R or S? So we must know what is the priority. So what is the OH priority? Okay, OH priority is 1, aldehyde priority is 2, CH2OH priority is 3, so hydrogen priority is 4. So now whatever the structure is on paper, is this R or S? Priority you know now. So most of you are answering R. So okay, now let me make like this structure. Now so now let just see this structure. In this structure, do you able to see hydrogen? Do you able to see hydrogen? No. Why? Because it's behind carbon. Okay, it's behind carbon, so it's away. Now tell me, this is clockwise or anti-clockwise? This is clockwise or anti-clockwise? As per priority. As per priority, you have to see from there. How come anti? This is priority number 1. this red color one, yellow is priority number 2, green is priority number 3. So 1, 2, 3. It's a clock. 1, 2, 3. It's a clock. So you have a 1, you have a 2, and you have a 3. 1, 2, 3. So it's a clockwise. 1, 2, 3. 1, 2, 3. So now if you see like this, so 1, 2. Now tell me, it is clockwise or anti-clockwise right now? Right now, is it clockwise or anti-clockwise? It's anti, so it's a R. So it's a R. Why? Because it's anti, but hydrogen is towards you. You know, the what is happening now, right now? Right now, what is the clockwise or anti-clockwise? You are able to see this one currently. On the paper right now, it is there. It is clockwise or anti-clockwise? How anti-clockwise? I don't know. This is 1. So this is 2 and this is 3. So now this is clockwise or anti-clockwise? You see, red is 1, yellow is 2, green is 3. It's a clockwise or anti-clockwise? Ritu, Ras, how it's anti? Red is 1. Someone is saying clock, someone is saying anti-clock. Anyway, I don't want to confuse you. Why? Because this is red is 1, yellow is 2, green is 3. So you are able to see from the top. So your eye is on the hydrogen. Your eye is on hydrogen. Now tell me, your eye is on hydrogen. Your eye is on hydrogen. And you have a 1 hydroxy, 2 aldehyde, 3 CH2OH. Now tell me whether anti or clock. Again, you have your eye is your hydrogen, this one. Your eye is this hydrogen, so your side, right? On this is on table, this is on my table, and you are on top here. Anyway, right now on camera it is clockwise. On camera it is clockwise. And in real sense, in front of my table, it's anti-clockwise. So what I'm trying to tell you, the real molecule, what is in front of me, this one, this is right now in front of me, it's a 1 2 3, 1 2 3. So right now it's a anti-clock, but as I visualize from the wave camera, it is clockwise. So that's why my answer and your answer is different. My answer is 1 2 3, that is anti-clock, but your answer, when I keep my finger on screen 1 2 3, then it is clockwise. So when I keep my finger on red 1 2 3, then it's anti-clock in the real molecule. But when I keep my finger on wave camera, the picture 1 2 3, that is clockwise. So what I would like to tell you, that mirror image is non-superimposable, and right now this is the example. Molecule, I have a anti-clock, you have a clock. So you see, this is your side. So your eye is suppose white at this point. So it's very clear that you have a red 1, then yellow 2 and green 3. So you are getting whatever you have in your hand, you are getting this one, right? So what on the wave camera you are able to see, that one is very simple, that is 1 2 3, that is clock. But for me it's a anti-clock. Anyway, this molecule, actually when you visualize from this way, then this is 1 2 3. So now tell me, this one is clock or anti-clock? This is clock or anti-clock? Oh, for you it's a clock. Sure. 1 2 3, 1 2 3. Can you confirm me it's a clock? 1 2 3, left hand. Oh, surprising. Okay, so it's a good 1 2 3. It's a clock. If it's a clock, it's R. Anyway, I'm a little bit surprised because what in the wave camera, what I am able to see, that is anti-clock, but what is in my hand, that is clock. what you are getting, that is clock. So anyway, I cannot go in your place right now. So, but this is in the real sense, this is 1 2 3, and right now it's a clockwise, it's a R. So it is, I am holding in my left hand and this is my right hand. So this is 1, this is 2, this is 3, this is clockwise, this is clockwise. And when I am rotating this one clockwise in my wave camera, it is coming anti-clock. So my hand is rotating in real sense is a clockwise, but on wave camera I am getting anti-clock. I don't know what you are getting on. Configurations cannot be changed. Yes, because of the camera I am facing this issue that in my hand this is clockwise, but in camera I can see the anti-clock, but you are getting the clock. So I hope you able to understand that. So you are getting this one clock or not? Just let me confirm. You are getting this one clock or not? Okay. Means the real one you are getting. I am getting the inverse one. So whatever what I can see on my hand, that is the same you are able to see. But on my screen it is just reverse. Okay, good. So this is R. So this is R. Now you have a mirror image. So now tell me, what about this molecule? This is R or S. This is R or S. Any confusion? This is S. This is R. This is R. Both is mirror image of each other. Both is mirror image of each other. Hello. So these two are the mirror image. One is R, one is S. Okay, so much sound. And these two are non-superimposable. Whatever the way I want to superimpose, it cannot superimpose on each other. So non-superimposable mirror image. So these two are the enantiomer of each other. That is the reason that these two is a non-superimposable mirror image. So I hope that you are able to understand what is the mirror image relations and why we call it enantiomer, because it's a non-superimposable. So if there is no mirror image relation, just wait, lot of here sound noise is going on. Okay, so yeah, I understand some work is going on backside in the department. So anyway, so now you understand the what is mirror image relation. So if you have a mirror in front of you and these two are the mirror image of each other and that is non-superimposable, this is mirror, right? So if there is a mirror and both is non-superimposable mirror image, then it is called enantiomer. But if there is no mirror image relation, that is called diastereomer. So what we understand, very simple, enantiomer and diastereomer. Enantiomer having a mirror image relation, diastereomer doesn't have mirror image relation. But what is common in both? Both is non-superimposable. So these two cannot superimpose, and if these two cannot superimpose, means these two molecules are totally different. These two molecules is totally different. It looks only same, but this molecule is totally different. So this is the, you say, take home message for us, that both molecules is totally different. Chemistry wise it is different, and of course if chemistry wise, atomic wise it is different, means everything is different. So this is the enantiomer, understand. Now my next question for you is, now I would like to now do you have any question about, because when we stop this enantiomer diastereomer, means we are not talking right now about optical activity. Okay, another thing is that, another question, that can we rotate this one and can we convert this, suppose this molecule is A and this molecule is B, can we rotate this one by any way and can we convert A to B or B to A? Is it possible by any kind of a rotation or translation? My question is clear to you all, that you have a two molecule, you have a molecule and you have a B molecule. My question is that by any way, rotation, translations, these rotations, can we convert A to B? No, not at all. So we cannot convert it. So that is the reason these two is called configuration, because it cannot interconvert by rotation, by translation, or by any means. Yes, if you can break the bond, suppose now you see, if I can break this bond and green I will fix at the yellow place and yellow I will fix at the green place, then only A and B will be superimposable. So I need to break the bond. So okay. So, sorry, some work is going on in the backside, another room. That is the reason that drill sounds are coming from there. Anyway, now I was trying to discuss with you all that you cannot make the same one by any translation and rotation, but you have to break the bond to make it same. So this is the reason that these two are called configuration and these two configurations are different compounds that cannot interconvert with each other. So I hope these things is clear to you all, because we would like to discuss conformation. Now we have completed the configuration part using this example of enantiomer and diastereomer. So now I would like to come on this point. This is another molecule you have. So this is the another molecule, and what is the name of this molecule? Can anyone can tell me what is the name of this molecule? Good. So it's a butane, and total 4 carbons you have. So basically this is butane, and you have a total. Yes, okay, no problem. We'll give you 5 minutes before, okay? No issue about it. So what I am saying, this is your butane, and now let me rotate it. Let me rotate it. Now you see, this is also butane, right? This is also butane. This is also butane. Now tell me, this is butane A, and this is butane B. Two butanes you have. Now tell me one question, whether butane A and B are superimposable or non-superimposable. You have a butane A, this is butane A, and you have a butane B. Now I'm saying this is both A and B is non-superimposable. Correct, absolutely correct. Now tell me, A and B having any mirror image relation? A and B, is there any mirror image relation between A and B? No. So what is that? Then what we can call butane A and butane B? What the single word definition we can call, enantiomer or diastereomer? Because butane A and butane B is non-superimposable. Butane A and butane B doesn't have mirror image relations. So my question is that whether that are enantiomer or diastereomer. Enantiomer must have a mirror image relation. Enantiomer must have a mirror image relation. So there is a no question of enantiomer. So because as per diastereomer definitions, both compound should be non-superimposable and both compounds should not have mirror image relation. So mirror butane A and butane B is actually diastereomer. So it is fine. We can call it diastereomer. But in fact, now my next question, whether so much sound. Okay, so now my next question is that molecule A and molecule B is interconvertible or not? So it's interconvertible. Why? Because there is a possible of single bond rotation. There is a possibility between the single bond rotation. So what I am trying to say, that if you have a rotation possibility, free rotation, CC bond, single bond free rotation, then another conformer can be created and both conformer will be interconvertible. And due to that, this butane A and butane B is called conformer. So we are able to explain now conformer. Now tell me one thing. Here, suppose you have a 4 atoms. So what is dihedral angle? Suppose you have a let me change this 4 atom now. Yellow is your 1. Yellow is your 1. So you have a 1, 2, 3, 4. So now tell me, what is dihedral angle? So yellow is 1, then 2, then you have a 3, then 4. Now tell me one question. You have a total number of 4 atoms. How many plane we can draw? How many plane we can draw? Using these 4 points, 1, 2, 3, 4, how many planes we can draw? 6 plane. How? Can we draw with 2 points any plane? Can we draw using this 2? Can we make a plane with using these 2? Using these 2, can we make a plane? Only lines we can make, right? Now, can we make one plane with 3 atoms? Can we make a plane with 3 atoms? With 3 atoms, can we make a plane with 3 atoms? Why not? 1, 2, 3. One plane, one triangle can come. Why not triangle can form here? Right? So this is simple that one plane can form using the 3 points, right? 3 atoms. 1, 2, 3. 1 yellow, 2, 3. Now you have another atom. So you can make 1, 2, 3 one plane and 2, 3, 4 another plane. Any confusion here? So only 2 planes is possible, right? So suppose you have a like this. So only 2 planes can form. Here you see. We can use yellow, black, black, one plane, red, black, black, another plane. That's it. This is the only 2 plane. So now let me rotate it like this. Now you just think, if I'm preparing a one plane using yellow, black, black, one plane number 1, black, black, red, another plane, plane number 2. Now tell me, what is the angle between these 2 planes? What is the angle between right now these 2 planes? What is the angle between 90-degree, correct? So because you have only 2 planes, so 90-degree angle between 2 planes. So now tell me, what is the angle between 2 planes? What is the angle between these 2 planes in the current situation? 0 or 180? 0 or 180? Now what is the angle between 2 planes? No, this is 180. Just opposite, 180. Now you see, what is the angle between these 2 planes? What is the angle between these 2 planes? 0? 0? Yes. Now maybe 60 degree. Now maybe 60 degree. Now maybe 60 degree. Now maybe 90 degree. Now maybe 90 degree. Now maybe 180. So 0, 60, 90, 180. Is it clear? So what we are changing? Just dihedral angle. What we are changing? Just dihedral angle. So how the dihedral angle is so important to have a different conformer? How dihedral angle is so important to have a different conformer? So basically one conformer and another conformer, the basic difference is the dihedral angle. So we need to control, we need to understand the conformer with the help of dihedral angle. So I hope you are able to understand how we can change the dihedral angle and how we can get the different conformer. So what is the name of this molecule? Now let's see. I can rotate this one. So just take an example. Take any 4 atoms. 1, this hydrogen, 2, carbon, backside carbon, 3, this hydrogen, 4. So just consider only these 4 atoms. 1, 2, 3, 4. 1, 2, 3, 4. Let me change color. Yes, or like this. So you see, now you have so many atoms, so many dihedral angle. So we should not confuse. That is the reason I am changing the color, so that you will focus only on the colors, so that you will focus only on the dihedral angle. This is my purpose. So basically, you see, this is also ethane, but one of the hydrogen is yellow now. Okay. So now total number of 4 atoms start from yellow, yellow, black, black, yellow. 4 atoms. Right now, what is the dihedral angle considering only these 4 atoms? Can you tell me? What is the angle, dihedral angle? Just considering this yellow one, yellow, 2 yellow and 2 black, 0, 0. So this is called eclipse structure. This is called eclipse structure. At 0, these 2 is so close. This 2 is so close. So that is the reason this 2 is so close. And that is the reason this structure is called eclipse structure. That is called unstable structure. Now you rotate this one little bit with 60 degree. Now you see, now you have a 60 degree. So you have rotated basically the dihedral angle, that is 60 degree. Now tell me, what kind of this conformation, whether this is eclipsed or this is staggered? Whether this is eclipse or this is a staggered? Is this eclipse or staggered? This is called staggered. Why? Because it's away. Now these two cannot touch each other because it's a 60 degree dihedral angle. All atoms are now separated. All atoms are now, you see, now from that side you can see the backside atom also. That is the reason this is staggered and it is away. But if you make it eclipse, so from the front side you can see only 3 atoms, because backside 3 atom is eclipse now. You are unable to see from there. So because here so close these two, that is the reason that unstable. So we are able to explain a conformer with the help of stability. Okay, so I think you would like to go for quiz. So let me stop today only, no issue. And you just let me get your attendance. So anyway, I'm expecting that you should study this slide and you should understand these conformations, and from the next class we will try to finalize the conformational examples. Okay then, thank you very much. Just all the best for your quiz. Thank you.